Good morning, good afternoon, good evening. Today we will make a three-phase part winding start. This is a 2 voltage winding motor. So we can connect them in one star and parallel star. This is one set of winding and this is the other set. We're going to connect this one tied together. This one tied together. That is forming one star and this is another star, so that is parallel star. We are going to connect this one. We are going to connect this one and start this one first. So that is the one star. This one is energized after the first one. This one in reality is already connected inside the winding. If we say 1, 2, 3, 4, 5, 6, this will be 1, 2, 3, 4, 5, 6. This is 7, 8, 9, and 10, 11, 12. Or this one is input, input, join or tied together, join or tied together. Okay. Then this will be to the lines, to the lines, to the lines, to the line, to the line. That is equivalent to parallel star. This one is energized first. Then this is single star. So sometimes if the voltage is given this way, there are several ways to connect this one according to the characteristic of the motor. There is a series star. There is also a parallel star. It depends on the configuration of the motor inside. So let's say one star and the next one is parallel star. So we will say dual voltage, or in reality this is done because you can connect them possibly in high and low voltage. Just refer to the motor's nameplate if that is possible. Let's say we're using the one voltage here. It's 230 only, but energize the half winding first, then energize the two windings together in parallel. We need how many contactors to do this one? This one is one contactor. This one is another contactor. But we need to switch off later. We'll see. So this one is the first uh, contactor, K1. And later we'll connect this one. So we need another contactor. We'll just try. Based on the standard start stop and the transition automatic. So we need timer. From one winding to two winding, we need timer, automatic. And where's the buzzer? We just place it here first. Okay, let's say start with K1, one winding, one winding star. Then after some time, timer will energize the contactor 2. So this one is always here, so giving power to both windings. So we need timer contact. T1, T1 also. We'll try. This should be K2. No, the same label. Later we will install it. We will connect house working area, no problem. Okay, one winding. So this is part of the whole winding. So that's why they term that sometimes as part winding method. The voltage here refers to the possible winding configuration that can be connected possibly in two voltage. Later on that. Next, we are going to connect this one here, and we need another contactor. Okay, maybe here. So we need to turn on ten, 9 to 10, and that way. This one to the lines after the overload relay. Means we have two windings in parallel, so we are doubling the current here. So the first one is one winding is half the current of the two winding. So you have low starting current. Then if the motor is already starting, let's say 3 to 5 seconds, the two windings will be connected in parallel. We need this change K2. So we just place this one here. So no more super input. That is overlapping of wires. Let's say in step operation. One winding, but we have 5 seconds there. We need this 1 second. So we can test. Right. You see if we need some interlock and extra safety contact, latching or whatever, we'll just see the main operation. Timer and one, it will turn on one winding. Then the two windings are connected in parallel. Okay, only the current of course is changed here. The RPM is the same based on the formula. We are not changing the frequency, we are not changing the number of poles. So only the current is changed here. Timer, no need to interlock because this one is keep on, this one is keep on. So we have this circuit. The other way around, if this is designed for series star and parallel star and you want that connection, if the motor is like that, just refer to the nameplate if it is possible. Usually it goes that way because the manufacturer can have bigger sales that they can sell their unit, their product that can be used to other countries. Let's say we have the higher voltage version and you want this in series star and parallel star or series delta, parallel delta. The winding series must be indicated in the nameplate. So refer to the nameplate. If for series star, that is high impedance. So you series the two. How to do that? Just series the two of this. We need this winding. Let's say for high voltage. So the connection to be done here is series star. So you series the two windings. In reality, this is already tied inside the motor's housing. This will be to the lines. So this is high impedance. So you need high voltage here. Here, that is different. Okay, one winding to 20 up to 30 volts. That is designed to handle twice the voltage. Of course, if you series, just refer to the nameplate. And you are going to parallel them, the same voltage. So you have double the current, double the power after the first winding synergize. You're going to series this one. So this will be to the lines 1, 2, 3. So you are going to use high voltage here. So you have series windings here. Next, the parallel star is this one, the equivalent one. So in low voltage configuration, okay, and this one is going here. It will be to the lines going here, going here. In some cases, if you want to start this way using contactors, you place contacts here, contacts here, contacts here. So that means this one to the lines. You're going to break this one, place a contactor here, contactor, and also this one because the first connection is series star. So how would you do that? Place a contactor here, here. If you are designing with conductors, okay, if you are designing this one just to run for high voltage and the other is low voltage, we will do it this way. The first conductor is here. We're going to energize one winding and this one is connected. They will act as one winding. This one. We're going to connect them in series. So high voltage. Of course, you have conductor there. Next, we are going to de-energize the contactor 1 and connect another contactor here. Okay, we will see. So this is the high voltage. If you want the low voltage, you go the parallel star. But in reality, if you are going to use contactors, you insert the contactors only here. Refer to the main connection and for reference, you can insert the contactor. Let's say here. And Since we are going to connect this one in double star, so connect this one here, connect this one here, and you need another contactor for the line of this one. So we have how many contactors here? 4 contactors. So this one, line 1, line 2, and line 3 respectively. Okay, remember why we place this one here? Because we are going to double star that one. Here no need, because we need the connection to be 1 star. Next, the same star. So no need to open this one. This one is series star and this one is parallel star. So we have to open that one. Open and close this area. This is why we need 4 contactors here. Little bit below. Okay, what is this for? This is for the series star. So we are going to connect this one here and this one here. This one here forming the series star connection, which we have done earlier without the conductor, but if we are going to connect that way, they alternate their operation. See, one winding series with the other, one winding series with the other, one winding series with the other. So that means this will be, they will operate 1 and 2. This will be K3, 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 K3 and K4 connected in parallel because they will form the double star connection. So this is K4. This is K4. If you need this one, so you connect this way. Are they independent with K1? K1 is always on. If K1 is always on, then you can connect this one here below K1. You see, K1 always with line. Okay, K1 is always connected, always closed. So we are going to connect them at the lower of K1. So how does it go? You will remove the label of this one, so they can function. It's a K5. You will raise them K5, not available in the schematic or control circuit. Otherwise, they will also function and they will make an error. Let's say K6, K6. Okay, one contactor at a time. You will energize later the other conductor. K3. Do we need interlock? We need some interlock there. You will see later. T1. You will cancel this one first. K1. Wait, where is the K2? This is K2. So where is the timer here? Okay, timer 1 is here. You will see that later. Here, no connection. K, 5, K6. Yeah, we don't have circuit breaker, that's fine. 1 and 2, then 3 and 4. We have to open this one because it will have short circuit here. That's why we need that contact here, and we need that contact also here to form Y connection. We'll just try outside the workspace area. Okay, let's say, okay, they're forming a series star. Wait, K3, because it's now under the, we're going to stop operation and in step at this one. Uh, okay, next. Okay, that is the connection, one winding and forming a one star. Next, we're going to turn off K2. So in that case, K2 has no interlock yet, so we are going to interlock this one. We are going to turn off K2 and K3. I mean K2 only. Turn on K3 and K4. So we are going to interlock this one with timer contact. At the same time, the contactor contact for double interlock. Okay, timer contact first. T1. Parallel. Do we need latching contact? You will see. Okay, here. This one is open because the voltage will go there and will make a short circuit. If you want the transition is closed, well, another use of power resistors transition here is open. That means the voltage across the winding is open at some point. We're gonna step this. Step. Yeah, because we don't have circuit breaker. Do it again. Oops, we don't need that. Series, let's say 3 seconds. You just put there 1 second. Okay, you see here, all windings are open. So that is open transition. In reality, there is some mechanical jerking in the motor, especially if the load is bigger. But that is designed that way, and the effect is not that big. You can do open transition. Closed transition, again with the use of power or wire wound resistors. Forming one star, forming another star. And you can connect the overload relay. After K1, here, we're using only one motor. Again, always refer to the characteristics of the motor's nameplate, if that is possible. The other way around is delta or parallel delta, single delta or parallel delta. Wait. In some cases, you can have series delta, parallel delta. So this is it. We call this one as part winding method. One part of the winding, then parallel winding. The other way around is using the characteristics of a 2-voltage motor. Now, you may ask, why there is only one voltage there? The winding is, let's say, 2 voltage, but you can operate that also in 1 voltage with half the voltage in parallel. I mean, half the current connect in parallel. Series, the other way around. Series, this is half the current, 1 voltage there. Next, parallel is twice the current. Next, if you want the high voltage, you are going to disconnect this one. Transfer to your power center, your power requirements, your power transformer there that is capable of giving 2 voltages in your operation. But sometimes that is a special connection. So you need 2 transformers there in your, I guess 2 because the control is 1, the other one here is the original voltage, and the other one here is the extra voltage. You can do that way. So don't misconstrue or don't get confused with that arrangement. This one is to operate in 1 voltage. Remember, if that is your requirements to connect this one in series and parallel with 1 voltage, or you need the 2 voltage, so you need another transformer here. If you have 3 voltages, because this one is lower voltage than the 2, let's say this is 110 volts, and you have the next voltage here of 230 and 460 or different way, you need 3 transformers. 3 or 2, I guess. So this is it about part winding or 2 voltage motor. Thank you. Please like, share, and subscribe. Have a good day.